Okay, so the answer to number 3, you can see there is -1. Yes? Guys, it obviously depends on who's taking the thing, but there normally are quite a lot of marks for a question like this. Usually you get 1 mark for each reduction that you do. So let me just show you. So that first line could be literally worth 5 marks. And then there will be like 1 mark for getting to the answer from there. So it's 1, 2, 3, 4, 5. And then a mark for getting to -1 in the end there. Right, so that could be a 6-mark question. I don't think it's that bad. We are going to add in some negative angles, some numerical angles, and then angles in terms of 90 and 270, right, which we treat slightly differently. But we're going to follow the same method for all of these. Okay, every time we're going to figure out which quadrant it's in. We're going to take the sign in that quadrant and then simplify and then see if we can cancel out going forward. Any questions on number 3, guys? What was the answer to number 1, by the way? -1. Okay, I will do it. Sorry, you didn't have to do 5. See, I have 3, 4, and 5, not 1, 3, and 4. All right, there's number 4. The answer was just 1. Guys, please remember for the ones that are squared, they will just become positive. All right, because whether it's a negative or positive, when you square something, it will become positive always. So you can see that for these ones, I didn't even write whether it was negative or positive in the first place. Okay, they will just become positive. Yes. Yes. Yeah, so if you have this, that will become positive. A little squad there coming back from the coffee shop. Yeah, but if you square negative anything, it becomes positive. See, thank you. So that's why I just made them all positive right away. Okay, fine. Did you have negative cos squared x and negative? Oh, so you would lose marks, but what for this one here? For number 3, yeah. So they do look at each one separately. So if you're missing negatives there. So guys, this is something that is quite important. I'm just going to go back up to number 3 quickly because you can see it there. You might notice that, okay, that is going to be negative and that's going to be negative. So if I multiply them together, it's going to become positive anyway. And then you might think, okay, I can just leave out the minuses. You do actually have to write the negatives down. Okay, you get a mark literally for saying that sine 360 minus x is negative sine x. And that this one is negative tan x. If you are leaving out the minuses there because in your head, you know that they're canceling out, the marker is going to think, oh, you thought that they're positive. Okay, so if you don't write negative sine x, if you do that, they're going to say, no, that's wrong, because it's not positive sine x. It's supposed to be negative sine x. Okay, so you have to show each reduction separately, and then you sort out the minuses after that. Yes? Yes. Yeah, you would probably, yeah. So I don't know. This one just doesn't feel like a 7-mark question to me, but it might, because you might get a mark for changing tan to sine over cos. Yes. If they were like cos squared x plus sine squared x, after you did the reduction, then would you be able to change that to a 1? Yes. Okay. Yeah, I think we did that in one of the examples that we did yesterday. Yeah, so the identities, wherever they appear, whether it's in a prove that question or in this, or even when we're doing trig equations later on, you can always use them. Okay, let's look at some reductions with numbers. So without x's, but just with numerical stuff. So we are writing, sorry, let me just get my notes here. Oh, let's do some negative angles first, actually. So let's just make a new heading, negative angles. It's very much the same thing. I just want us to think about these as well. I'm just going to write down some examples of negative angles so that you can see how we're going to work with them. For the ones that we've done so far, they've been quite rigid, all right? So you see 180 minus theta, and you know immediately that's quadrant 2. 180 plus is quadrant 3. 360 minus is quadrant 4. For the negative angles, you're actually going to have to figure out quite often where those angles lie. So I'll show you now how we're going to do that. So if you have, for example, cos of theta minus 360 degrees. Now, if we have to simplify that, we're going to need to figure out which quadrant this angle is in and then take whether cos is positive or negative in that quadrant. Okay, so guys, it is useful to have a cos diagram on the side. I'm just going to draw mine here. It can be quite a small one, because now we're actually going to have to figure out where that angle is in. You could do it without a cos diagram, but I think just for these first ones, let's use it. So we have A, S, T, and C. We know that this is 0, but it's also 360. That is 90. That is 180, and that is 270. Okay, now we also need to remember that theta always represents an acute angle, okay, unless they say otherwise. So if we're saying theta minus 360 degrees, theta, the first part of this angle, will be in the first quadrant, right? Because it's an acute angle. So from somewhere in the first quadrant, we are then minusing. So now we're going to go the other way around, right? If we're saying plus 180 or whatever, we'll go in the positive direction. If we're saying minus, we're going to go in the negative direction, okay? So we're starting at theta, which is somewhere in the first quadrant. Then we are minusing 360 degrees. Do you see that we end up back in the first quadrant again? All right, so this angle theta minus 360 is going to be in quadrant 1. And you literally have to think, guys, okay, theta is in quadrant 1, then I go 360 degrees backwards, and it will get me back to the same spot. Okay, now what is cos in the first quadrant? Positive. So this is just going to turn into positive cos theta. Right? It's always the numerical part that you kind of cancel out. All right, that just becomes cos theta. You can, yes, it's just that there are going to be so many of them that you couldn't possibly really put them all down. But yes, you can if you want. Okay, let's do another one. If we have sine of negative 180 minus theta. Okay, so we're starting at 0. We're going to negative 180. Now, when we're moving into the negatives, we're going backwards, right? So negative 180 is going to be there. And now we need to minus another acute angle from it. So still moving backwards, we're going to move into the second quadrant. Okay, I'm going to show you that again. From 0, we always start at 0. We're going to negative 180, which is over there. It's the same as positive 180, right? But then from there, we have to minus another acute angle. So it's still moving backwards. We're going to end up in the second quadrant. Okay, does that make sense, guys? If it was 180 minus theta, we would say 180 is there, and now we're minusing an acute angle to get to the second quadrant. This is similar. It's negative 180, so we're minusing 180 degrees, all right, and then we're minusing an acute angle as well. Right, so we end up in the second quadrant. What is sine in the second quadrant? Hold on. Sine is positive, hey? So positive sine theta, yes? The first one, this one. So theta is in the first quadrant somewhere, and then you minus 360. You go all the way around. Okay, so you end up in the same spot. This one again, from 0 to negative 180, but then we need to minus another acute angle from it. All right, so we're actually minusing an angle that is bigger than 180 in a sense. All right, yes. Yes, theta is always an acute angle, yeah. Okay, we're going to do some more, guys, and then we're going to do some examples as well, like more complicated ones. If we have tan of theta minus 180 degrees, okay, so we start at 0, but now they're saying theta. Theta is in the first quadrant because it's an acute angle. And now we're going to minus 180 degrees from it. So it's almost like you're going like that, right? When you're minusing 180. If you were here and you're minusing 90, you end up there, and then you minus another 90. That will get you to the third quadrant. Okay, so 180, remember, is like a straight line, guys. So if you start here, if your angle theta is there, and you need to move 180 degrees, you're going to move to that spot over there. Maybe that makes a bit more sense, right? If you're minusing 180 degrees. So that angle is in quadrant 3. What is tan in the third quadrant? Positive. So that becomes positive tan theta. Okay, last one of these simple examples that we're going to do is just sine of negative theta. Now theta is an acute angle, right? So where is negative theta going to be? Robert? Between 0 and 90. Yeah, so I just made a point there, so that would be the angle, right? It's just any acute angle. Yes, Jasper? Yes, negative theta would just be in quadrant 4. You're just moving. Imagine if it's like negative 30. Negative 30 is over here, all right, in the fourth quadrant. Theta is always an acute angle, so you're just moving an acute angle backwards from 0. So that will always land up in the fourth quadrant. What is sine in the fourth quadrant? Negative, so this one becomes negative sine theta. Okay, let's do a more complicated one. I'm just making another star. This is going to be a fraction now. I'm just going to write it over 2 lines. Okay, now this is similar to the homework that you did, right? We have 4 angles here that we're going to have to reduce so that they're just written in terms of x only so that we can cancel them out. So the first one, I'm just going to rewrite this 2 over here. 180 minus x, we know that that is in quadrant 2. If you forget that, guys, you can use the same approach that we used for these top angles. You can think, okay, 0 is here. We're going to 180. And now we are subtracting an acute angle from it. And that ends us or lands us up in quadrant 2. What is sine in the second quadrant? Positive. So this just becomes sine x, positive sine x. Times negative x. We just discussed that one, but just to revise, negative x is a negative acute angle. So that will land you up in the fourth quadrant. What is cos in the fourth quadrant? Positive. So that one just becomes positive cos x. Right, negative 180 minus x. We discussed it up there, but let's just take a look again. We're starting at 0. Now we're going to negative 180. And then we minus another acute angle from it. So we go further into the negatives. All right, so that will end up in quadrant 2. What is sine in the second quadrant? Positive. So that one just becomes positive sine x. Okay, then the last one, x minus 180. This is the one that I actually drew in on the picture, right? So x would be an acute angle, so anywhere in the first quadrant. And then we minus 180 degrees from it. So that will end up in quadrant 3. What is cos in the third quadrant? Negative. So this one becomes negative cos x. Okay, now that everything is written in terms of x and we have one term over one term, we can cancel out. So we have sine x and sine x. There we have cos x and cos x, and I'm left with negative 2. Okay, so it's just a different way of thinking, guys. You just need to be able to basically figure out where or in which quadrant the angle is in, even if it's one of those that we haven't gone over. All right, so they can ask you, yeah, all sorts of negative angles. You'll see when you practice these. Okay, that's it for the negative ones for now. We're going to do, sorry, my pages are all mixed up. Numerical reductions with special angles now. That is the next heading. So we can just carry on underneath this. Okay, guys, if you hear the term special angles, which angles am I talking about here? The ones in the special triangles, right? So those are 30, 60, and, well, not really, but yes, but 45. Those are the ones that I'm talking about. But yes, you do have a 90-degree angle as well. All right, but those are the three that I'm thinking about when I say special angles. We need to use our special triangles to find the values of the trig ratios of these angles. Okay, so we're going to bring that into the mix. We're just going to jump straight into examples, guys, so that you can see how we're going to use reduction formula if we have numbers, not x's or thetas. Okay, it is slightly different. So we're just going to say simplify the following. And now, of course, the instruction is going to say without the use of a calculator, which we have been doing all along. Hey, with these ones, like this one at the top here, we didn't use a calculator for this. Okay, so we do know what to do. It's just going to be a bit more complicated. Simplify the following without the use of a calculator. So guys, that means that if we have sine 30, we can't type sine 30 into the calculator and give the value. We're going to have to draw our triangle and use the triangle to get those values. Okay, without the use of a calculator, we're going to have to draw those triangles. So the first one, we're going to do two examples like this. They're giving us the following fraction again. So we have cos 240 times sine of 315 times tan of 120 over sine of 150 degrees times tan of 210 times cos of 225. And we have to simplify that without using a calculator. Sorry. Now guys, what we're going to have to do, and we kind of did it when I was trying to explain reduction formula to you guys, which didn't go very well, but but you'll see now why I did it in the first place. What we're going to have to do here is we're going to rewrite each of these angles, because do we see we don't have any angles at the top and at the bottom that we can cancel out right from the start. Okay, and if you just type that whole thing into the calculator and write an answer, you're going to get 0 because you haven't followed the instructions. So we are going to use 180 plus, 180 minus, 360 minus to rewrite all 6 of these angles in terms of our spatial angles, in terms of our 30, our 60, our 45. Once we've rewritten those angles, we're going to use reduction formula to simplify them, to reduce them, and then you'll see we can just use our triangles after that. Okay, so we're going to say cos of 180 plus 60, isn't that the same as 240 degrees? 180 plus 60. I know you can also do 270 minus 30, but I'm putting that on hold. There are different rules for 90 and 270. Okay, so we're just working with 180 and 360 for now. We're going to do the other ones tomorrow. Yes. It's kind of like a yes and a no. I don't know if people will really take marks off, but we're supposed to. Yeah. Well, you'll see that the final answer is going to just be a number. Try and remember to put it in. Okay, just in case. Okay, what can I do for 315? How can I write that in terms of 180 or 360 and my spatial angles? Jasper? 360 minus 45. That will give me 315 degrees. The next one, tan of 120. I can write that as 180 minus what will give me 120? 60. 180 minus 60. Good. Okay, the next one, sine of 150. So we're not doing 90, right? 180 minus 30, good. So sine of 180 minus 30 times tan of 210, that's the same as 180 plus 30, hey. Last one, cos of 225, that's 180 plus 45 will give you 225 degrees. Now do we see that these kind of look like our 180 minus x, 180 plus x, 360 minus x, all right? So now we're going to do exactly what we did when we worked in terms of x, but we're going to not end up with a cos x, we're going to end up with a positive or a negative cos 60. Okay, so we're going to cancel out the 180s and the 360s. We're just going to have our acute angles, which will then allow us to use the triangles. Okay, so when we are now simplifying this, 180 plus 60, or just 240 degrees, it's the same thing. What quadrant does that one lie in? 240 lies in quadrant 3, hey? 180 plus, if it's easier to think of the 180 plus part, it might be 180 plus x or theta is always in the third quadrant, right? So this is a quadrant 3 angle. What is causing the third quadrant? Negative. So this now becomes negative cos of the acute angle that is in that bracket. Guys, just to remind you, the reason for that is because if you were to draw a 60-degree triangle here, or a 240-degree triangle there, it would be the exact same triangle, but you would just have a negative side in the 240-degree one, which is why we're changing it to negative cos 60. Okay, you will get the same value, just a negative answer. Times 360 minus is quadrant 4. What is sine in the fourth quadrant? Negative. So this becomes negative sine 45. Times. Now we have tan. 180 minus is in quadrant 2. What's tan in the second quadrant? Negative. So that becomes negative tan 60. Yes, Nina? Fine, Robin? I'm just doing it so that I don't kind of miss that minus. So you don't have to put brackets around it, but there's just, yeah, you might get confused with the signs if you're working fast. Okay, the next one, 180 minus quadrant 2. What is sine in the second quadrant? Positive. So this becomes sine 30. Tan of 180 plus. 180 plus is in quadrant 3. And what is tan in the third quadrant? Positive. So this becomes positive tan 30. The last one, 180 plus, that's quadrant 3. What is cos in the third quadrant? Negative. So this becomes negative cos 45 degrees. Now, guys, I can use my special triangles to find the values of all 6 of those ratios. Okay, and that's what we're trying to do. We're going from something that we can't actually find the values of without using a calculator. We're using our knowledge of reduction formula to reduce them to acute angles. All right, and those acute angles have to be special angles so that we can find the values. Now, let's draw our triangles, please. You don't have to draw them as big as mine. You can draw them smaller. Oh, you guys are even confusing me. I think that's right. 1, 2, 3. Guys, a way of remembering where the lengths go is the shorter length must always be opposite the smaller angle. Okay, so I don't know if you knew that. That is why in a right angle triangle, the hypotenuse is always the longest side because it's bigger, it's opposite, sorry, the biggest angle. So in this case, 1 is shorter than root 3. You can type that into the calculator. I think this is like 1.7 or something. I'm not sure now. So 1 has to be opposite the 30-degree angle. Root 3 is opposite the 60-degree angle. And then 2, the longest one, is your hypotenuse. In the other one, oh, sorry, I haven't folded in. It's 1, 1, and then root 2. Again, you must know this off by heart, guys. Right? You have to memorize those triangles. You can't just put it in your calculator. What do you mean? Yes, but if you put it into the calculator, it will sometimes give you what's it called? A rationalized one where we don't want that. That's a giveaway that you use the calculator. Okay, negative cos 60. Negative, we're looking at this triangle. Cos 60 is adjacent over hypotenuse. All right, remember cos adjacent over hypotenuse. So 1 over 2. So cos 60 is a half, but that's negative a half, right? Or what we can do it from the start. Let's actually cancel out the minuses that can be canceled out, right? Because we're going to do a negative times a negative is a positive. And then we have 2 more negatives. So that negative divided by this negative is going to be another positive. Okay, so you can actually do that there. Then we don't have to carry on working with negatives. Sorry about that. So our whole final answer must be positive. Okay, because there are 4 negatives altogether. So cos 60 is a half. Now we're going to multiply that by sine 45. Now you have two 45-degree angles to choose from here. You can work from either one. Sine is opposite over hypotenuse. 1 over root 2. Guys, please do me a favor. Type sine 45 into your calculator quickly. I just want to show you something. Sine 45. You still get 1 over root 2 if you type it into the calculator. No, the calculator gives you values with where the denominators are rationalized. You remember we did that when we did surds. All right. A calculator or the calculator will never give you an answer with a surd in the denominator. And that is how we catch you out. Because if you write root 2 over 2 instead of 1 over root 2, we're going to know, oh, you didn't actually use your triangle, you used the calculator, and then you're going to lose that mark. Yes. You would have to show that. Yes. Yeah. And they might sometimes say that you have to leave your answers with rationalized denominators, but then you have to show I'm multiplying the top and the bottom by root 2. Okay, you would have to write that in. Yeah, that's fine. Okay, next one, tan 60. 60, tan is opposite over adjacent. Root 3 over 1. So I'm just going to write root 3. Okay, that is then over sine 30, opposite of hypotenuse. Sine 30 is a half. That's quite nice. The half at the top is going to cancel out the one at the bottom, right? We can show that as soon as we notice that. Tan 30 over here, opposite over adjacent, 1 over root 3. Again, guys, if you type tan 30 into the calculator, it will give you the rationalized value. So again, if you're not using your triangle, we will see that there. All right, it will give you root 3 over 3 instead of 1 over root 3. But if you're working with your triangle, you have to get 1 over root 3. And then cos 45 is actually going to give you the same value as sine 45. So we're going to get adjacent over hypotenuse, again 1 over root 2. No, they're not exactly the same. We have root 3. So we have to show that here. We're not going to cancel it out. Yes, but you have to actually. Yeah, well, you're not really canceling. You're not actually going to get 1. You're going to get 3. You'll see now. So guys, we're left with root 3 divided by 1 over root 3. What do we do when we divide by a fraction? We tip in times. I'll be with you now, Robin. So we're going to say root 3 times. Now, if we tip this, it is currently 1 over root 3. When I tip it, it's going to become root 3 over 1. Or just root 3. And guys, you will have to show that step because you're supposed to do this all without a calculator, right? So root 3 times root 3 is just 3. Robin, yes?
So if all the negatives don't cancel out, then what do we make we just make all the numbers negative or fraction?
No, well, it's one fraction, it's one term. So you would just put that minus in the front of the whole thing. So your final answer would just be negative 3. If you put a minus with each term, then it's again going to cancel out. Well, with each fraction, I mean, because it is just one term and one term. Yes. Yeah, so this would be a lot of marks. I'm not sure. They probably won't ask you one with so many reductions because that's 6 marks for doing the same thing multiple times. But I suppose it will be 1, 2, 3, 4, 5, 6. And then maybe, oh, you'll get a mark for your triangles. That's the other thing, guys. As soon as your triangles are drawn for a question that it needs to be used, you get the mark. So even if you can't do the question, if you just figure out, oh, I'm probably supposed to be using my triangles for this question, and you draw them, you will get a mark. I know what a lot of people do is they'll draw their triangles at the beginning of their whole paper, all right? Even if it's not drawn like next to this question, say this was question 7, and you drew the triangles right at the top of the whole test, we will go to that where it's drawn and we'll give you a mark there. Okay, so that's maybe a nice thing to do. At the beginning, just draw your triangles, then you will have a mark, definitely. Yes.
What would you give them one of this that's not added?
You could, yes. All right, just back to the marks. So we said that it would be 6 marks there, 7, 8, 9, and then a mark for the final one. So 10 marks for this one. But guys, they probably won't give you one with so many reductions that you have to do. Okay, because yeah, you're basically getting 6 marks for doing the same thing multiple times. All right. Any questions on this one, guys? Okay, I'm going to give you one to do on your own. Yes. Okay, guys, I want to give you one to do on your own quickly, and then we'll mark it. Okay, it's just that one, yeah. No problem. Okay, that one, please. You can just ignore my triangle here. I drew it. The top, that one, please. Do that one. Thank you. Number 2. The instruction is the same. Simplify without using a calculator, and that is the question. Okay, please just do that one on your own. Guys, another thing, if you've drawn your triangles once in a question paper and a test, you don't have to draw them again. Okay, so for this question, you don't have to redraw the triangles. You can just use them from that one. You won't get another mark for drawing them again. Yeah. It's a special angle in the testament. Yes. Yeah. Yes. fine if you just write 1.
Yeah, but then it's times 3, so you don't need times 3 times 1.
I would do it just, yeah, just in case, because you are going to show the other fractions anyway.
Okay.
So you're gonna have your 3 and then your 1 and then your other fraction, yeah.
So you have a call. You make the cross sometimes the way that you should up or down. Then go right.
Yes. And those triangles that we did at the beginning in the different quadrants, yeah. What are we doing? 3 to 5. Oh, I actually remember there was an issue with, sorry guys, let me just check. I did them 3, 4, 5. Not as many big ones that I have tend to accumulate files as you teach for years and years. Okay, so we are doing exercise 8, 3, 4, and 5. Okay, 3, 4, 5. The other one is just 3 and 4. Okay, guys, let's get going, please. It's important that you practice these, yes? You could, so you'll see in number 5, you are actually going to have to change the tan at the top, you're going to have to change the sign of the cos and get a compound fraction, which you must then multiply the top and the bottom by cos. So that can also happen. Yeah. And guys, sometimes in these questions, I think in the textbook, they tend to put questions in where you'll get a number as your final answer, but sometimes you will end up with like a sign or something. And in that case, can you listen please? In that case, they'll say simplify. So instead of just saying simplify the expressions as far as possible, they often say simplify to a single trig ratio. So you need to make sure then that you don't have like a sine x plus a cos x, or like a sine x over cos x. It has to be a single trig ratio. So then you must simplify that as possible. Yeah. This is on page 147. Any other questions? You get 1 off the 105 with 1. You don't get them wrong for that. Yeah. Yeah, so the thing to remember with sine squared, cos squared, sine squared will always just be positive. So you can actually just change it to sine squared x straight away. Because this is supposed to be negative sine x squared. I know that we explained it. Anything that's negative, that's squared becomes positive anyway. Yes, number 3 and 4.